Welcome to the third lecture on two-port network. We are discussing about network parameters. So we discussed about Z parameters and Y parameters. Here we are continuing our section. From the previous section we discussed what is Z11 is equal to V1 by I1, and what is Z22? Sorry, what is Y11? V1 is equal to I1 by V1. Is it clear? Can we write Z11 is equal to 1 by Y11? Correct only, right? Is it correct? Z11 is equal to V1 by I1. This is just a reverse of that only. So 1 by Y1. Is it correct? No, it is not equal. Why it is not equal? What are we missing here? Very important thing. Z11 is not V1 by I1. The statement is not complete. We have to also write I2 is equal to 0. This is, we have to also write V2 is equal to 0. So these two are not equal. Z11 and Y11 are not equal. If these terms are not there, if these two terms are not there, then these two would be equal. But here these two terms are present, so we cannot tell those two are equal. Other important point is, can we write Y is equal to Z inverse? Is it correct? Y is a matrix, Z is also a matrix. Can we write? Yes, of course we can write. How can we prove? We know that V is equal to Zi. Correct? We are pre-multiplying with Z inverse. What will get? Z inverse V is equal to Z inverse Zi. So pre-multiplying with the same number or same matrix, it won't change the result. So what is Z inverse Z? This is identity matrix. So identity matrix into I will be equal to I. Identity matrix is like 1 in our normal arithmetics. So it is 1 into I will become I only. So same logic is applicable here. So this will become Z inverse V. Interchanging RHS and LHS, what will get? I is equal to Z inverse V. So what is our expression for Y parameters? I is equal to YV. So if we compare these two, what will get? Y is equal to Z inverse. Similarly, reverse also true. Z is equal to Y inverse. So matrix inverse, if we find, we'll get, if we find the matrix inverse of a Y matrix, we'll get the Z matrix. Hope it is clear. Now let us move to third network parameter, that is ABCD parameter. It's also called transmission parameters. What do you mean by a transmission? Transmission means here what we are transferring from input to output or output to input. What we are transferring? Current or voltage. So the parameters ABCD is about the transmission. So what should be the matrix? One side it should be either input or output. For ABCD it is input. We'll write LHS matrix as input elements. Input elements means input current and input voltages. Then the ABCD parameters, and we are transferring to output. What is output? Output is V2, and here there is a difference. I2 will consider as a negative. Y negative will discuss below. So this is the expression. We have to write ABCD here. So you'll get the expression V1 is equal to AV2 plus, sorry, not plus, it will become minus B I2. I1 is equal to C V2 minus DI2. Hope this is clear. So here independent variables are V2 and I2. Output is the independent variable and dependent variable is input. So we are transferring output to input. The output parameters we are transferring, we are getting, or we are getting from output parameters, we are getting the input parameters. That's why we are calling it as transmission parameters. Hope this is clear. And similarly from here also we can find we can define what is A is equal to, this term should be equal to 0 to get A. So what will be A is equal to V1 by V2 provided I2 is equal to 0. What's V1 by V2? This is the input and output voltage ratio provided output is open. Similarly, we can find other parameters BCD. We can define BCD. I'm not going here in detail. We can go through that. Now let us move to next parameters, that is H parameters. H parameter also called hybrid parameter. Why it is hybrid? Here the parameters are mixed actually, not input or not output. So for remembering easily, always will start voltage and always first one will be 1, V1 and I2. This is mixed, not V1 by V2. Input voltage and output current is the dependent parameter. We are writing in terms of V2 and I2. Sorry, I1 and V2. Always will write on top 1. So that's why what is missing, other two terms what is missing here will write here. It's remembering, it's very easy to remember, because always remember that you start with the voltage at top in a, let's just say it, whatever the expression we have taken, voltage will be at the top and the top element will be 1. Like that we can remember this. Then we can fill this H11, H12, H21, H22. So we can write the expression I1 is equal to H11 I1 plus H12 V2. Similarly, I2 is equal to, why it is hybrid, I hope you understood, because V1 and I2 we are writing input side voltage and output, it's hybrid. I2 is equal to, what will get, H21 I1 plus H22 V2. Hope this is clear. Or is this expressions, from this expression we can get what is H11. H11 is equal to, this term should be 0. To make that term 0, V2 should be equal to 0. If V2 is equal to 0, then V1 by I1. V1 by I1 is H11. This is clear, I hope. What will be H21? To get H21, what we have to make? This term should be 0, so V2 should be 0, I2 by I1. Then what is H12? To find H12, this term should be 0. So what will become? If this term is 0, then H12 will become V1 by V2, provided I1 is equal to 0. Similarly, all terms we can find. So the terms also we have to, the names of these terms also we have to just understand. H11 is called, what is this, V1 by I1, right? So this is a short circuit input impedance. This is also input impedance, but it is short circuit impedance. Whether it is equal to Z11, what is Z11? That also V1 by I1, but the condition is different. That is very important. There I2 is equal to 0. This is called open circuit input impedance. This is short circuit input impedance. So we have to analyze all these things. The questions we can frame anywhere, anyway. So we have to understand this term properly, understand logically, not by hurting the things. Hope it is clear. Similarly, we have another parameters called G parameters, inverse hybrid, or we will call it as inverse hybrid parameters. Same, just what we have written here is V1 by I2. What we have written here. So here it will become just I'll write the expression for this. What is I1 is equal to G11 V1 plus G12 I2. So here what are the parameters? I1 and I2. Then V2 is equal to G21 V1 plus G22 I2. So you can easily write this. This is just inverse of that what we have written before. Previously, we told always voltage will be on top, but only for inverse. This you remember. I will be on top, but always 1 is at top. I1 by V2. So this should be mixed. That is clear, right? Hybrid means the parameters I and input one parameter and output parameter. Already we have taken input voltage here. Now here we have to take output voltage and input current. So that's why always one should be at the top. This point is highest priority. So V1 by V1 I2, like that we can remember this. Then G parameters G11, G12, G21, G22, and we can write which should be at the top. At top it should be always 1. So which one? I1 is already there. So what one is missing here? V1. Then I2. Hope this is clear. So G11 V1 plus G12 I2. Then second V2 is equal to G21 V1 plus G22 I2. Hope this is clear. From similar way we can define what is G11. G11 is equal to I1 divided by V1 provided I2 is equal to 0. So what is this? This is open circuit input admittance. What is Y11? That is also I1 by V1, but here V2 is equal to 0. So this is the difference. Hope this difference is clear. Okay, let us stop our discussion about network parameters. We'll discuss next section about symmetric and asymmetric networks. Thank you all.